Good morning. Hi, everybody. Thank you for joining us today on Data Speaks, our latest edition with automation and AI in the utility industry. I'm the Chief Revenue Officer at Paradigm, and we'll be facilitating today's discussion with our panel of experts. Folks, you want to introduce yourselves? Maybe if we go with Phil, Gerald, Brad, and Hank.
Hi, everyone. This is Phil Zerang. I'm the Chief Innovation Officer for Paradigm Technologies and their IT Excellence Practice Executive. I've been with Paradigm for a little under a year now, and with about 25 plus years in various industry, mostly in the utility side. And I got really interested in machine learning several years ago. My passion is really making things better and figuring out how stuff works and optimizing it and improving it. And when I saw the capability that machine learning tied automation has for driving efficiencies and improving business, it got me pretty excited. It's been something I've been close to ever since.
Thanks, Phil. Gerald?
My name is Gerald Benson. I'm the CFO and co-founder at Nuclearn. And I've been in utility data analytics and AI for over a decade, straight out of college. And I just love AI and machine learning. And I'm so excited about all the opportunities it brings for automating and improving things that we've done the same way for a very long time and just generally make things better. So, and it's cool, which I enjoy as well.
Thanks, Gerald. Brad?
Hi, I'm Brad Fox. I'm the CEO and co-founder of Nuclearn. I've been in the nuclear industry for well over a decade, about half of which has been in analytics and data science, and the other half in nuclear engineering. I got really interested in automation from a really young age, and kind of the capabilities it brings to free humans from doing low value work. And so we've decided to implement that for all of the nuclear industry. Thank you.
Awesome. Thanks, Brad. Hank?
Yes, Hank Nelson, recently retired from Arizona Public Service, and I've got 40 plus years in the business. My role here is an industry advisor to the group, and my passion here has always been about reducing costs in any way we can, and I see this AI ML as an
Excellent. Thanks, Hank. I think you're freezing up a little on us. But Hank's got extensive industry experience. And in fact, this whole panel has over 100 years experience in the utility industry, including myself, which I've been working with utilities for quite a period of time. And this not only applies to utilities, this really applies to AI and taking knowledge work and using AI to augment that and enhance that, which we have some phenomenal examples and we'll really dig into it. But as artificial intelligence is just gaining lots of momentum throughout the business world, throughout the technology world. AI and ML products are enabling many new business decisions and solutions to some of the world's and business's toughest challenges. According to Gartner, worldwide, AI software revenue alone is forecast to be about $62 billion this year. A third of the organizations that are focused on AI say they're planning to invest about $1 million or more in 2 years, and 80% are actually just getting started. So we're really kind of at the beginning of this whole thing. So to start at the beginning, maybe Phil, can you kind of fill us in? What is AI and ML and what's the differentiating factors there?
Yeah, sure. I mean, we've been using computers to make business more efficient and more effective for many, many years now. And I'd say back in the early 2000s, the phrase of automation kind of kicked off with business process automation. And that was really about taking some simple business rules and explicitly telling a computer how to follow those rules. And that took off a lot of administrative activities from people, making business flow better. Worked pretty well. But it worked pretty well for some pretty straightforward, explicit, business flow type of items. In the 2010s, robotic process automation hit the scene and allowed automation to start working more on the operations side. And that really brought to the table the ability for a computer to write its own code based on copying what a human did. Right? So it brought replication of action. So if you hit the record button and the computer will replicate what you did and it'll write its own code to do so. And many of you are probably familiar with this from Microsoft Excel with the macro record feature. RPA took that to the next level. What machine learning based intelligence tied to automation really is new is instead of just replicating action by recording the thing the person did, you're now able to replicate judgment and decision-making based on all of the times the human made that decision. And so machine learning and artificial intelligence have really kind of opened the door to start to not just replicate action, but replicate judgment and tie that judgment then back to the action that needs to be taken. Give you an example, my daughter's getting her learner's permit. She's got a learner's permit right now, so we're learning how to drive. And the simple question of brake or gas when I hit a yellow light is incredibly complicated. The factors that involved, it's, how close are you to the intersection? How fast are you going? Is it raining? Is it snowing? Is there a big truck right behind you? Is the car in front of you going to stop? Is there a cop in the intersection? Is your mother-in-law sitting next to you? Is there a cake on the front seat? There's hundreds of different factors that go into whether or not you're going to hit the brake or hit the gas. And so when you think about how difficult it must be to train automated driving, to train a car to autonomously drive, that's just one example of brake or gas. And so it's beyond our real capacity to write millions and millions of lines of if-then, embedded if-then statements to intuit what that decision-making algorithm looks like. But it's a lot simpler to just hit the record button and let the computer figure out on its own, given all of this sensor input and the decision made by the driver, this must be the formula that they're using. And the great thing about computers, my daughter's learning how to drive for me, but the computer can learn how to drive from every driver that's hit the record button. And so when you take Phil's driving and you take that across 100,000 other drivers, you now have a huge data set of inputs and then decision made, inputs and then decision made. So machine learning is really the methodology for taking those inputs, looking at the output, what the answer was, and then intuiting from there what the formula must be for that decision to be made. And as a result, that car trained by 100,000 people is going to be much better driver than me or my daughter are going to be. And essentially that's what machine learning brings beyond what you've seen in automation in the past. And you see that judgment being replicated and then actions being taken. This is going to have tremendous implications. I think you're going to see an explosion of this in the next 10 years. And people are going to really start to think differently about the role of the computer versus the human and what roles that we can apply computer technology, specifically machine learning automation to. It's going to reshape, I think, how we're structured, how we're organized, and what jobs humans are doing versus people. And I think what Brad and Gerald have done in Nuclearn, specifically for corrective action screening and taking that judgment and automating it is a perfect example of a specific use case. Brad, you want to tell everybody about what you're doing over there?
Yeah, absolutely. So here at Nuclearn, one of our kind of lead products is taking corrective actions. So issues that may come out of a nuclear power plant or really kind of any utility or generation source, right? And we kind of augment the human process where they will take a ticket from the power plant and they'll screen it for kind of corrective actions. Who's going to own the ticket? What do we need to fix it? Is it really a severe issue, right? What kind of risk ranking does it get? A lot of times at most power plants and at most utilities, there's a group of people that kind of, they sit around, right? Really experienced people, and they analyze each one of these things. They'll assign it to the right group, right? They'll figure out the risks. They'll do all of the work to make sure that the issue gets to the right place and it gets fixed correctly. That's a lot of judgment type work, like you were talking about, Phil, right? It takes a lot of years of experience to learn how to do this properly, right? And it's a lot of kind of just thought, judgment, knowledge work. Fortunately, with AI, and actually in this use case, we have a lot of data around what kind of issues came in, what the humans decided. That allows us to really effectively train kind of intense AI models, right, that can replicate that same decision making with a high level of accuracy. And kind of, in fact, accuracy levels that approach or exceed human standards on some of these fields, which when applied properly, right, in kind of like an RPA fashion or an automation pipeline, lets us automate tickets coming out of the power plant and kind of reissuing corrective actions and making those decisions in an automated fashion extremely rapidly, right? And it really frees up the humans from the repetitive issues and lets them focus on issues that they need to spend time on. So in the nuclear world, this would be, issues that are very important to safety, right? Or have a high risk ranking or otherwise need kind of like human wisdom and those decades of experience to make an effective decision.
No, that's fantastic. Hey, it sounds like, I love your analogy, Phil, with your daughter and how that in driving experience and how that took you forward to thinking about how ML and AI really kind of impact that. And Brad, it's amazing what you guys are doing in Nuclear. You know, question, AI is transforming industries from logistics to healthcare to professional sports, which reflects the critical role companies see AI playing in driving efficiency, competitiveness, and customer value. Hank, I know what's been your personal experience. What do you see? What did you see during the delivering the nuclear promise, using technology to solve problems? Can you give us your insights there?
Yeah. First, I'd like to give a little bit of background about delivering the nuclear promise. Back in 2015, the chief nuclear officers partnered up with the Nuclear Energy Institute on an industry initiative to reduce cost, because many of the power plants that were still viable for generation were closing because they couldn't compete in the open market. And so these efficiency bulletins were developed with industry teams and to target certain business areas to reduce generation costs. So the biggest areas of success that I've seen ensure optimum plant reliability. And in addition to that, also with what Brad had discussed with dispositioning the three utilities I think that stand out the biggest with plant monitoring: Luminant, Duke, and Excel. They're leading the industry, and they have had several plant saves to continue to generate power when they saw certain equipment failing and able to recover from that.
That's great, Hank. Unfortunately, your connection's a little tough today. Phil, what are some of your experiences or AI ML use cases that you can share with that may resonate with others? Here.
I think I'll kick it over to Gerald to talk a little bit about their experience, what they saw building on Hank's experience working directly with the nuclear promise around both CAP and machine equipment reliability and equipment evaluation monitoring.
Yeah, sure thing, Phil. Like Hank mentioned, obviously some of the corrective action automation that we work on was one of the things under delivering nuclear promise, but he also mentioned condition monitoring and really using AI and machine learning to analyze the wealth of data that we're getting from sensors out in the plant to try and detect when equipment's having issues or having problems, et cetera. And as Hank mentioned, there's many utilities that have been doing this for a while and having a lot of success, and that's being able to better monitor your equipment, being able to use AI to reduce like preventative maintenance frequency, to take transition from corrective maintenance to proactive predictive maintenance is a huge value statement for utilities. And Brad and I at our time at APS actually worked on one of those use cases at Palo Verde as well. I think what's really interesting about the condition monitoring and equipment analysis use case is that it's a really good example of how AI and ML augment the human as opposed to replace. So if you've been at one of these utilities like Luminant, Excel, et cetera, that do this, you'll find that they don't have AI or ML just tell them what the issues are at the plant. They usually have a small team of people that look at all the issues that the AI or ML algorithms are identifying. So the machine learning is really good at looking at lots of data, telling you things that are abnormal or what you might want to look at. But to have an effective condition monitoring program, you have to have those people still in the loop that look at those issues that come in, figure out what the right thing to do about that is, and feed that into downstream processes. It's actually like a lot of what we do at Nuclear, and a lot of our experience out in the utility too, was not just developing a good AI or machine learning algorithm. We have even done use cases, even in the equipment monitoring area, we had an awesome AI model that was like really good, one that we actually were able to get a patent on. But that's not enough. You really have to have the right business process, the right software to integrate and expose those AI model results, and the right kind of software integration and design to take advantage of that. Your business processes, as you start to incorporate AI and ML, they don't go away, but they do change to take advantage of those capabilities. And it's sometimes not as simple as just turning on a machine learning algorithm and automating everything and never needing a person again. Maybe a couple decades from now, but not today.
Yeah, Gerald, I think the IoT component that you brought up is interesting because predictive maintenance has been kind of one of those holy grails in equipment reliability for a long time, and everybody can intuitively see the benefit of only having to work on equipment when it needs it, as opposed to on a time cycle or some other methodology. But the challenge is once you put in, several hundred sensors or 1,000 sensors that are collecting millisecond data, how many analysts and engineers are going to need to add to your organization to comb through all of that information to correctly make that predictive call. And so, being able to, you're quickly going to eat up the cost savings you would have gotten in maintenance when you have to add the analysis of the tremendous addition of data that you've got. And so being able to layer in some automated decision-making that's highlighting the things that really do need action for that analysis group or that engineering group is going to be critical to making predictive maintenance a reality using sensors and IoT devices. And this is a technology that I think is applicable across a lot of different industries. The automation of judgment has a huge implication for knowledge transfer. There's a lot of folks aging out in the workforce, retiring. There's been the great resignation going on. And so for these folks that have 20, 30, 40 years of experience that are making these judgment calls, it's really powerful to memorialize their judgment into an algorithm that's going to be there forever. That can essentially help not only train the next generation of workforce, but to take on a lot of that workflow and just leave some more of the fewer complicated, less time sensitive stuff to folks that can really deep dive and take the time to make the right call on. But taking a lot of the noise out of the system and automating a lot of the things that are may have many factors of judgment, but at the end of the day are pretty straightforward once you put all the pieces together. And I think that's going to be huge. I think you'll see that in medicine. You'll definitely see that in finance and financial analysts. There's already a lot going on in the accounting space in this way. Anybody that's in a dispatcher role or a scheduling or work management role, any kind of coordinator function, these are all areas that use a lot of judgment and take a lot of action that are ubiquitous, that I think this technology, you're going to see big strides in efficiency by leveraging machine learning tied automation in that space.
I feel a really good point and really good use of the great resignation, right? Because if you look at all that knowledge that's going away through this resignation process, what a great opportunity to use this technology to really fill that gap. And speaking about gaps, what's the biggest gap you see to getting the greatest impact in the shortest period of time? Gerald, what are your thoughts there?
Yeah, so I alluded to it a little bit earlier when I was discussing, but I think a lot of people don't realize when they're implementing a machine learning or AI use case that it's not just the machine learning model. And really, when you look at the best automation or AI use cases that have the most success, they have several different factors that contribute to that success, right? So first, you need a good use case, right? You need something that you can automate or use AI to deliver value, either by generating more revenue, reducing costs, time savings, et cetera. Most AI use cases, especially in automation space, you need really good ML models. So I don't want to discount that. You need good machine learning models. You need a vendor that can generate these very well, or a skilled data science team that knows your data and knows the right algorithms and modeling techniques to use. I think what a lot of people miss is to harness the benefits of AI or ML. Oftentimes, you need really solid supporting software. This is something that a lot of data scientists miss. But if you have a good machine learning model, but you don't have a way to interface that with people, right, in the decision makers or the people that are looking at this, you're going to struggle to get a lot of value. as I mentioned earlier, most effective AI use cases have a human in the loop component. And a lot of times that's overlooked and it's not designed for, it's an afterthought. And, it makes it a struggle to get the most value out of it, value out of the use case. And then one of the other gaps we see a lot of times too is, especially when it comes to automation use cases, is you really need direct integration back into your source systems. If you're looking at automating a business process, but you're not actually changing the data in your source system or your ERP or for utilities, Maximo systems, you haven't really automated much. There's still this human in the loop component to just do manual work. And it's very counterproductive to the whole intent of the process, which is to, get people not doing these manual automatable things, stepping back and taking a more, cognitive role and doing less of that low value added work. So those are, there's a lot of different gaps, right? But when I look at my, peers in the utility business and where I personally had, challenges implementing use cases as well, it usually doesn't come from the machine learning. It either comes from trying to solve the wrong use case, not developing the right software to actually interface with the human and get the value, or not having a quality integration back in your source system.
Got it, Gerald. That you covered a lot of bases there, especially the 4 components of the use case, the right ML models, the supporting software, and the integration back. Key components. Hank, you and I have been around for a while. What resistance have you seen with computers replacing decision making, and what do you foresee the challenges to be moving forward?
Yeah, so the efficiency bulletins that I mentioned earlier that came from the industry, several of them discussed automation of processes to target reduction of professional staff that Phil had mentioned, work management, business processes, and electronic work package business processes beyond PDF overlay system. There really wasn't any roadmap or details about how to automate or what resources were needed. So data scientists are an essential piece to automating these business processes. And these types of resources, they can be hard to find, costly, but like I said, they're definitely essential for these types of projects. And the other piece is, do I need somebody temporary? Do I need to hire somebody full time? How do these data scientists integrate into the utilities, which many of them have started their own innovation teams and groups, and so there's really a need for an approach for the utilities. How do they want to target it? What do they want to target? Because there are some folks out there, such as this group, and I think in the future the challenge is going to be developing the approach and how to integrate into the on-staff IT and innovation teams in the industry.
Those are really good points. Thanks, Hank. Data scientist is a key component to this whole thing. Yes, couldn't agree with you more. Hey guys, how do we get started? Down this path to really take advantage of all of the opportunities that are out there in AI and ML. Brad, Gerald, what kind of approaches can you take? What are you seeing?
I can describe our personal experience, right? And what we've seen has worked really well. I think the first thing would be to start small, right? If you're a utility data scientist working towards an automated use case, you have to start small, get your hands around a use case that you can execute and implement, I'd say probably inside of 6 months, right? And prove to the business that you can deliver value in the use case, you can automate the task, right? And really deliver value back to the business. I think a lot of times people like to look at 2 to 3 year large projects that are expensive, and a lot of times success is hard to measure when you're in the middle of that. If you start small and iterate quickly, right? I think that's a good recipe for success, to kind of iteratively build value, right? Demonstrate value, demonstrate your engineering processes as you develop that, and really kind of get your feet under you quickly, right? And understand how to solve the problem. Starting small for us has always worked really well, right? And iteratively building the large solutions. We do the same thing at Nuclearn, right? We start small in one use case, build one small model, And a lot of times what we thought we were going to build at the beginning ends up changing by the end. And if we didn't iterate, we would have never found, kind of an optimal solution. I'll let Gerald add on if he has anything else.
No, I think you really nailed it, Brad. And I think that recommendation isn't just for AI or ML. You see it a lot of the utility space too, where it's almost like people are afraid to get started, right? It's like they don't really know what the space means. Like Hank mentioned before, people don't really have a roadmap for how to move forward. So they sit in kind of analysis paralysis, right? It's like AI and machine learning is so big and complicated. How could I, ever hope to implement that at my utility without knowing exactly what we're going to do? And the ironic thing is that's the exact opposite mindset of what's productive. It's, it is kind of complicated, which means you got to start doing it. You got to start seeing how it works with your utility. You got to start seeing how well the models are going to work on your data. You got to start seeing whether it's something that your data scientists can solve, whether it's something you need to partner with a vendor for, whether it's even a solvable problem at all. And you can't do these things by, first starting with just the roadmap and not actually doing any of the work itself. So it's not to say that you shouldn't reach towards developing that longer term plan. The argument is that you start doing today, you start small, you learn about what AI machine learning is, what it means for utility and how to do it. And now you can go into that planning step, into a roadmap step, having that knowledge and being more confident when you look at those larger investments, knowing that you're going to get the return on investment on it and that it's a worthwhile thing for your utility. So just really reiterating what Brad said, it's like start small, start today, like what's stopping you? And go build.
Yeah, I think
the worst thing that happens is you spend a few hours, you find something that doesn't work, you move on to the next thing.
Yeah, just to reiterate, a lot of times people struggle with finding the initial opportunities, right? So there's several solutions here, which is, a lot of utilities have kind of like improvement opportunity programs, right? Or just internal frustrations from your team. So if you have a good set of data scientists or even internal candidates that, have expressed some interest in computing, programming, or data science, right? Kind of let them loose on the business side and go find where there's internal opportunities, right? Frustrations in the staff, processes that may be inefficient, right? And solve one small piece of that, right? And that really helps. And it's helped us a lot in our careers, demonstrating that initial value and kind of getting traction inside of the organization.
Yeah, Brad, I think you bring up a really good point. It's so common in pretty much every company that there's this gap between IT and a particular line of business where you have the technology experts that know what machine learning is, they know what automation is, they know what capacities and capabilities current technology has, but they don't necessarily have the knowledge of the judgments that are being made or what the day-to-day work looks like in every single knowledge worker across their entire company. And on the business side, they certainly collectively know that information very well, but they don't necessarily up to speed on the technology, what it can do, how much it costs, if it's if it's even reasonable to try to solve this problem with technology or not. And so you tend to see this kind of big divide, and that divide can be bridged from either direction. If you're in IT and you want to solve business problems, you can start in closing that gap from your side. If you're in the business side of the company and the operations side or another department, and you want to leverage technology to solve your business problems, you can bridge that gap from that side. It just takes some methodology to close those gaps. It takes some visioning, some road mapping, some journey mapping to figure out, okay, what are the use cases? Let me learn a little bit more from either side of that problem. Let's put a list together of some small things that we can get started and see what works and iterate the way that Brad and Gerald described. But it definitely helps to close that gap so all parties are involved. And I know what Hank's experienced and I've experienced is people are afraid of new technology, and they're certainly afraid of whether or not a computer can do the job better than someone with 40 years of experience. And so having that human in the loop and having those expectations understood and closing that gap is a big part of that. And that's certainly something we focus on at Paradigm, is closing that gap and helping companies see that journey of where they could go and the types of problems they can solve with this latest technology.
Yeah, and a lot of times, right, the same concepts work with an outside vendor like us, They work with an outside provider, right? Whoever your resource provider is, that could be internal data science, it could be an outside vendor, it could be a large vendor, really anybody. But I still think that start small, iterate quickly approach works fine, especially in a regulated industry, right? Like nuclear. There's usually a lot of people that have, they want to withhold information potentially, right? Or they're kind of cautious as to fully automating a task like screening corrective actions. But once they see that the accuracies are there, right, you can prove the model does work. We've seen people kind of convert over and be advocates like really quickly, right? Including, regulatory organizations who you might not think would quickly get on with a project like that.
All really good points, gang. The whole idea of, think big, start small, and then build that confidence through that iteration component can really have a really big impact on the companies. And as you said, and you guys really kind of nailed that. A couple of the questions that have come up in the question and answer session. The first one is, hey, is this something I can do myself? And do I have to hire someone to do this? Not quite sure who asked the question, but Phil, you want to take a shot at that one to start with? Then maybe Gerald or Brad could pick up from there.
Sure. Yeah. I mean, it obviously it depends on the scale and scope of what you're trying to do, but unless you've got a department of experts that are familiar with doing this, you're probably in a good position to either hire someone to help put a strategy and a plan together for you, or to source a solution that already exists, or source some experts that understand the models and the integration components. You're seeing a number of RPA solutions out there that sell you a platform that you have to configure and program and learn. You also see some enterprise items out there that are doing specifically machine learning, AI platforms like Google or IBM Watson, for example. But that is just an underlying platform. There's still an awful lot of work that you have to do in order to solve a niche problem or a specific area of knowledge automation that you want to automate. And so I would say if the solution out there already exists and it's real and it works, that's going to be your easiest path to success is grab the thing off the shelf that does what you need it to do. Otherwise, you're in for a little bit longer investment, but you want to go into that with a good plan and strategy, because it certainly is something you can do yourself. You just have to be prepared to do so.
Yeah, and to add on to that, Phil, just even if you have internal data scientists, right, or you have a data science team, it's often a good idea to augment those, with either contract staff or other things like that. So when Brad and I were starting at Palo Verde, obviously that's one generation site in an entire fleet APS, right? So a relatively small number of use cases. Even we augmented or supplemented with some other data scientists as well. It's a good way to scale up your team, right? It's a good way, especially when you're dealing with AI and machine learning, to bring on specific skill sets. Machine learning is a very wide field to study. There's lots of things people specialize in or are good at. And it's often a good idea to bring people in that have some experience solving the type of problems you're trying to solve, even when you have like on staff data scientists as well. So just throw that on there.
Yeah, another point there, right, that I'd like to make is there's a difference between a capability provider. So if you're using like something like Azure Machine Learning Services, right, they're very good at solving very specific use cases, like pulling text off of a driver's license or off of a form, for example, but they don't provide a solution to an automation problem, such as using that information to actually drive business value. So a lot of times you would need internal resources like data scientists to actually take those very niche, custom tailored capabilities and deliver a business solution from it, right? So I'd be in a way cautious if you're getting started to just believe a large vendor like Watson, as Phil said, or Azure Machine Learning Services, something like that, right? Where they say they can solve the problems for you, because they do have really great solutions. They just need to be utilized in the right way, usually by very specialized staff. Where, on the other hand, a solutions provider, like, not to be biased, but like Nuclearn, right, can deliver a fully tailored solution, that works from end to end and solves a specific challenge, right, for a business.
Got it. Really great points. But you guys really have some great expertise here. Hey, Phil, an interesting question. I think it probably directed towards you, and that is, hey, what if I'm not, what if I'm not a utility company? How would Paradigm come and work with my innovation team to to drive this type of use case identification and adoption.
Sure, yeah. I mean, it kind of goes back to closing that gap between what's possible and what's needed on the business side and what's the capabilities of the technology are. And doing that journey map, looking at, what are the personas or the functions that you get a tremendous value from automating? Where are those cost reductions or quality improvements or speed gains that you're going to get from that automation technology? What a lot of companies struggle with, to iterate or to go agile or to start small and go big, is a lot of times in the justification. So we can certainly help you with that, understanding the justification. In utilities and other large fixed asset companies, capitalization is a critical component of that versus using their operating expenses. And so how do you write that justification that allows you to start small, iterate, learn, while still capitalizing a fixed asset and having that knowledge of the fixed asset accounting and the FASB rules associated with building a program that builds in that flexibility in that iteration, that has a somewhat executive view of prioritization so that the most important business problems to solve and can stay focused on solving those versus receiving lots of different requests from lots and lots of different people. And then having that prioritization method really tied directly to the value streams that you're going to produce. If you're using an agile model like Epic trains or epics and value trains, or if you're using some other model for execution, that's really the key. It's what's the vision of what you're trying to achieve? What's the business value? How do you justify it within the framework of your company? And then how do you lay out an execution model that allows you to be flexible, agile, and iterate while still meeting the business expectations and the policies and the processes that exist within your company? So that's really the great way to guide a company through this. It's applicable to utilities, but it's applicable to everybody, even more so if you're regulated and have a lot of constraints on you internally.
Excellent. Thanks, Phil. Hey, I think we have a couple of call to actions. Thank you everybody for your time today. A couple of the call to actions that we have are there's things you can take advantage of from this team. For example, a Nuclearn demo. Brad or Gerald, do you want to talk about that a little bit?
Yeah, I can talk about that. So, obviously, one of the things we do at Nuclearn is provide AI and automation solutions for the nuclear industry, and including some utility use cases as well. Brad and I have been doing this for half a decade in data science. I've been doing AI ML, at the utilities for even longer. We have a lot of really good software and good solutions that solve your use cases. And if you want to see how that can work for your utility or your nuclear site, let us know. Demos are really easy to set up, and we love to show off our software. So just contact us, and we'd be more than happy to set something up.
Fantastic. Thanks, Gerald. Hey, and from the Paradigm side, we are fortunate enough to have Phil and our digital practice as well, and the two combined to really do AI and ML vision and strategy roadmap sessions. And it doesn't matter if you're using AWS technology, Azure, or more importantly, Nuclear, and we can come in and actually do a great strategy and roadmap session to combine both the business use cases, the business challenges, along with the technology to find the right solution and the right roadmap for you. So please take the opportunity to take advantage of that. We appreciate all your time. You'll find, if you want to refer back to this, you'll see we'll forward out the URL for it. We'll also be available on YouTube, and we can make a transcript available for you as well. Thank you very much for your time and everybody for joining. Hopefully we've answered everybody's questions, and we'll look forward to seeing you on the next Data Speaks. Thanks, everybody. Make it a great day.